Hello students, today we are going to compare the all digital modulation scheme which are already studied like ASK, FSK and PSK. So let us revise this scheme. So types of the digital to analog modulation. So the output will become summation minus infinity to infinity AI of t cos of 2 pi ft plus theta of t. So this A parameter is nothing but the amplitude with respect to time varying. This F parameter is nothing but the time varying frequency component, and this is nothing but the time varying phase component. So this is the standard equation for the digital modulation scheme. So the digital modulations or digital to analog modulation technique can be categorized as the amplitude shift gain, frequency shift gain and phase shift gain. And the one more technique is nothing but the quadrature amplitude modulation, where amplitude and phase can be changed. So the bit rate is the number of bits transmitted per second, that is RB is equal to K into RH. So bit rate is nothing but the number of bits transmitted per second. The second parameter, important parameter, is the baud rate, is the number of the signal elements transmitted per second. So that is baud rate is equal to RB, that is bit rate divided by the K. So baud rate is the number of the signal elements transmitted per second. In the analog transmission of the digital data, if the signal unit is composed of the k bits, then the bit rate is k times higher than the baud rate. The baud rate determines the channel bandwidth required to transmit the modulated signal. So these are the three main schemes of the digital modulation system. So in digital communication, the modulating baseband signal M of t is a binary or M-array digital data stream. The carrier is usually sinusoidal signal. So this is the first signal is the baseband digital message signal. So this is one is in the form of the 1 and 0. Analog sinusoidal carrier signal, that is AC, is equal to cos of 2 pi fct plus pi c. So this is the carrier signal. The third signal is nothing but the ASK, where ASK is available for the 1 bit and it is 0 for the 0 bit. So this is the ASK, that is the message signal changes the carrier's amplitude. In FSK scheme, the message signal changes carries the frequency. So for the 1 bit, the high frequency is available, and for the 0 bit, the low frequency is available. In the PSK phase shift keying, that is message signal changes the phase carriers. That is, if the transition from 1 to 0, so negative phase is available, that is the 0 bit is transmitted, and the digital data is transited from the 0 to the 1, so the positive phase is available. Again from the 1 to 0, negative phase is available. In this way, all digital systems works. Types of the digital modulation system. First one is the amplitude shift keying ASK, which is also called as the on-off keying, or binary amplitude shift keying BASK. Second one is the frequency shift keying, that is it is also called as the binary frequency shift keying. It can be converted to 4-level frequency shift keying. Next one is the phase shift keying. So there are many forms of the phase shift keying, that is binary phase shift keying, quadrature phase shift keying, differential quadrature phase shift keying, pi by 4 quadrature phase shift keying, open phase shift quadrature phase shift keying, 8 levels of the PSK, 16 levels of the PSK. So depending upon the applications or output end, so different PSK forms can be built. Next one is the quadrature amplitude modulation QAM. So there are different forms of the QAM, like a 16 QAM, 128 QAM, 64 bit QAM, 265 bit QAM. Next one is the continuous phase modulation, that is minimum shift keying and Gaussian shift keying GMSK. The performance advantages of the digital modulation technique, modulation when we compare to the analog modulation. Digital modulation or digital transmission produces the fewer data rate than the analog transmission. So it provides the data integrity and noise immunity, that is easier to detect and correct the information bearing data errors since the transmitted data is a binary which is in the zeros and one. Error coding is used to detect and correct the digital transmission errors. Regenerative capability is available. So that is regenerative digital repeaters placed along the transmission channel and can detect a distorted digital signals and retransmit a new clean digital data signal. These repeaters minimizes the accumulation of the noise and signal distortion along the transmission channel. So this is the first advantages or performance advantages. Second advantage is the permits the higher transmission data rates. That is economical to build the transmission links for very high bandwidth as well as the optical fiber designed for the digital transmission. It provides the better spectral efficiency. That is the third point. Efficiency use of the limited frequency resources, that is a narrow bandwidth to spend the large amount of the data. And the fourth one is the security and privacy. It enables the encryption algorithm in information bearing digital bit stream signal, detects the phone cloning and ever dropping. It is easy to multiplex the multiple sources of the information like a voice, video and data in a single transmission channel since all signals are made up of ones and zeros. The next performance advantage is the easy to integrate, that is a computer or communication system. And the next one is the digital equipment consumes the less DC power in similar physical size. Disadvantage are the more bandwidth is needed because the transmission of the digitally encoded analog signals requires significantly more bandwidth than simply transmitting the original signal. It has the circuit complexity because the analog signals must be converted into the digital pulses prior to the transmission and again converted back to the original analog form from the at the receiver. So additionally encoding and decoding circuits is needed. Again the third more disadvantage is the synchronization. It requires the precise time synchronization between the clocks in the transmitter and at the receiver. So this is the typical block diagram of the digital communication system in detailed structure. We already studied this, but this is the detailed structure of the basic digital communication. So where the data source may be the audio or video, it provides to the anti-aliasing low pass filter. Again it sent to the sampling and analog to digital uh, converter. So these two blocks combine the source encoder. After the source bits is generated, it provides the channel encoder where different schemes can be used. That is forward error corrector, ARQ, that is automatic repeat request block or convolution. Again, it sends to the pulse shaping filter to remove the intersymbol interference. Again, it is fed to the these two blocks called as a baseband. Again, it is passed to the passband where passband modulators can be used. Maybe the modulator ASK, FSK, PSK or binary or MRA. It again fed to the multiple access like a FDMA, TDMA and CDMA depending upon the input. It sends to the bandpass filter and it sends to the communication channel, maybe the analog or digital one. The path at the communication channel, the disturbances like path loss, noise, distortion, interference may arise. After the at the receiver side, that is RX. So this is the receiver side. So there is a bandpass filter to remove the noise. Again, multiple accessing scheme to extract the signal. Again, decoder, demodulator and detect. So here envelope detector are available to detect the different signals or coherent type or carrier recovery is done. It is sent to the regenerator. Regenerator may be the match filter, the decision devices or timing the recovery. Again it is fed to the decoder where reverse action done as per the channel encoder. Again it is fed to the D to A converter where an original signal can be recovered and that signal will be band passed by the low pass filter where the noise can be removed and at the user you will get the output. So this is the basic block diagram of the communication system. So this is the working of the communication system, that is source encoder samples the and quantize the time and amplitude varying analog signal and conveys the samples into the digital binary bit string ones and zero. Then encoder it into the shortened digital, that is reduce the redundancy and reduces the bandwidth requirement or like a data compression. That is, the goal is to minimize the signal distortion. At the channel encoder, it accepts the digital signal, encodes it into the longer digital signal by introducing the redundant data bits in the information sequence for the purpose of combining the effects of the noise and interference in the transmission channel, thereby minimizing the transmission errors. At the modulator, the converters digital information data sequence into the high frequency carrier waveforms that are compatible with the characteristic of the transmission channel, which varies the amplitude, phase or frequency depending upon the carrier waveform or used modulator. Transmission, the carrier modulated digital symbols are transmitted towards the described destination using the certain physical medium like a cable, optical fiber, unguided or wireless media. Channel estimation. At the channel estimation, the transmission channel may introduce the distortion to the source signal, and the characteristic of the channel distortion need to be estimated or identified at the receiver end. And in order to reduce or eliminate the distortion and recover the original signal, this is called as a channel estimation or identification. So the first modulation scheme is the binary ASK, that is amplitude shift gain, where its bandwidth is B is equal to 1 plus D into S. So for the 1 bit this amplitude is available, for 0 bit the amplitude is 0. So this is the modulator of the ASK, where digital data input is applied and the second input is the carrier frequency, and at the end you will get the modulator ASK output. FSK, the first signal is the digital signal, second signal is the carrier signal, and it is applied to the modulator. Then you will get the zero at the zero frequency, zero bit. There is a low frequency, and for the 1 bit there is a high frequency. So the output will become a cos of 2 pi f1 of t for binary 1 and a cos of 2 pi f2 of t for the binary 0, and the bandwidth will become 2 RB plus F1 minus F2. FSK, the P is less and SNR is known. That is, the probability of error is less and signal to noise ratio is high. This technique is widely employed in the mode design and development. It has increased the immunity to noise but requires the larger bandwidth compared to the other modulation types. To overcome the drawback, BFSK, two-level binary FSK or multiple FSK modulation techniques with more than two frequencies have been developed, like 4 FSK, 2 FSK. So different frequencies can be available. In MFSK, that is a multiple FSK, more than one bits are represented by each signal element. BFSK, that is a phase shift keying. First input signal is the digital data, second is the carrier frequency. So at the bit 0 degree is available, and for one phase is reversal, therefore at the 180 degree. So for the binary 1 it represents the a cos of 2 pi fct, and for the binary 0 a cos of 2 pi fct plus bar, and bandwidth is equal to 2 into RB, that is 2 into bit rate. In PSK, the probability error is less and signal to noise ratio is high. It is a power efficient system, but it has lower bandwidth efficiency. PSK modulation is widely used in the wireless transmission. PSK have the forms like PSK and ASK modulations are the QAM modulation. So there are many forms: QAM, 16 QAM, 64 QAM, 128 QAM, and so on. So this is the detailed comparison of the ASK, FSK and PSK. In ASK the amplitude is changed, in FSK frequency is changed, in PSK phase is changed. Bandwidth is B is equal to 1 plus D into S. D is due to the modulation filtering and lies between 0 and 1. Here the bandwidth is 1 plus D into S plus 2 delta f, and in case of the PSK bandwidth is 1 plus d into s. Noise immunity is low at ASK, it is high at FSK, and again high at PSK. Complexity is simple in ASK, moderately complex in FSK, and very complex in PSK. Error probability in ASK is high, FSK is low, and in PSK it is also low. The bit rate is the performance in the presence of the noise ASK is poor, FSK better than ASK, and PSK better than FSK. Bit rate, it is suitable for 100 bits per second. The second system FSK, it is suitable for 1200 bit per second, and PSK, it is suitable for high bit rate. Thank you.